We gaze up at the stars, pinpricks of light in the vast cosmic ocean. We see them as symbols of constancy, of serene beauty. But this tranquility hides a violent truth. Some of those distant lights are not peaceful beacons. They are cosmic time bombs. What if one of the universe's most violent spectacles, the death of a massive star, happened right next door? In a previous video, we learned that black holes don't suck in the way you might think. But a supernova? A supernova absolutely shreds. It is the ultimate stellar swan song, a cosmic explosion so powerful it can briefly outshine its entire home galaxy of billions of stars. And if one were to go off in our galactic neighborhood, well, let's just say, not pretty, is a catastrophic understatement. To understand the threat, we first need to understand the beast. We're not talking about a star like our sun. We're talking about a true giant, a star at least 8 to 50 times more massive. For millions of years, this stellar behemoth lives a furious life, fusing elements in its core. Deep inside, under unimaginable pressure and heat, it crushes hydrogen into helium, then helium into carbon, carbon into oxygen, and so on, creating progressively heavier elements in concentric layers, like a cosmic onion. Each of these fusion stages releases enormous amounts of energy, which pushes outwards, fighting a constant war against the star's own immense gravity pulling inwards. For millions of years, this battle is a stalemate. But then the star creates iron. And with iron, the star signs its own death warrant. You see, fusing all the elements up to iron releases energy. But fusing iron? That consumes energy. The moment the star's core turns to iron, its furnace switches off. In less than a second, the outward push of energy vanishes. Gravity, the patient victor, wins instantly and catastrophically. The core collapses upon itself at nearly a quarter of the speed of light, shrinking from the size of the Earth to a city-sized ball of ultradense matter in an instant. This collapse then rebounds in a titanic shockwave that blasts the star's outer layers into space. This is a supernova. And you do not want to be anywhere near it. So, how close is too close? Scientists generally agree that the kill zone for a supernova is anywhere within 50 to 100 light-years. The danger follows something called the inverse square law, meaning the destructive energy decreases exponentially with distance. A supernova 10 light-years away isn't just twice as bad as one 20 light-years away, it's 4 times as devastating. Thankfully, there are no known supernova candidates within this immediate danger zone. The famous red supergiant, Betelgeuse, is a prime candidate to go supernova, but it sits at a relatively safe distance of about 640 light-years. The first sign wouldn't be an explosion. It would be a light. An impossible light. A new star would appear in our sky, rapidly growing brighter until it outshone Venus, then the Moon. It would be a terrifyingly beautiful beacon, clearly visible even in broad daylight. We have seen this before. In 1054 AD, astronomers in China and the Arab world recorded the appearance of a guest star. It was so bright it was visible during the day for 23 days. What they were witnessing was a supernova over 6,500 light-years away. Today, we can still see the spectacular aftermath, the Crab Nebula. Imagine that light, but not from 6,500 light-years away. Imagine it from 50. The awe would quickly turn to dread, because that light is just the prelude. The real killer is already on its way. The first truly devastating punch would come in the form of invisible, high-energy radiation. A lethal blast of gamma rays and X-rays, traveling at the speed of light, would slam into our upper atmosphere. Their primary target, our planet's fragile ozone layer. This shield, which protects us from the sun's harmful ultraviolet radiation, would be stripped away in a matter of months. Without it, our own sun would become our enemy. Unfiltered UV radiation would pour down, scorching the surface of the Earth. Skin cancer rates would skyrocket for any humans or animals exposed. More devastatingly, the very foundation of our food chain, the phytoplankton in the oceans, would be wiped out. This would trigger a mass extinction event. Following this, a storm of high-energy cosmic rays would arrive, inducing a powerful electromagnetic pulse, EMP. Power grids would overload. Satellites would be fried. our entire global communication network would be rendered useless. We'd be thrown back into a dark age on a dying planet, but the assault isn't over. For thousands of years, the blast wave itself, the expanding shell of gas and dust from the exploded star, would wash over our solar system. This wouldn't be a single impact, but a long, relentless storm of radiation that would prevent the ozone layer from ever recovering. Earth would be rendered a sterile, radioactive wasteland, its surface uninhabitable for millions of years. This is a truly terrifying end-of-the-world scenario. A story of absolute destruction. But it's not the whole story. Because here is the most profound and mind-bending truth of all. For all their destructive power, supernovae are also the ultimate source of life. They are the cosmic forges. Remember that iron core? Every element in the universe heavier than iron was created in the unimaginable heat and pressure of a supernova explosion. The gold in our jewelry, the silver in our electronics, the uranium that powers our reactors, all of it was born in the heart of a dying star. These explosions are how these elements get distributed across the galaxy, seeding interstellar clouds with the raw materials for new stars, new planets, and new life. The calcium in our bones, the iron in our blood, the oxygen we breathe, every atom in your body that isn't hydrogen or helium was forged inside a star that lived, died, and exploded billions of years ago. That terrifying event we just described is the reason we are here. We are, quite literally, made of stardust. We are the children of supernovae. And it's a humbling reminder that the universe can be both breathtakingly beautiful and utterly, terrifyingly violent, and that sometimes they are one and the same.